So, hi everybody. Sorry for this voice, but I could do no better than that. What I'm trying to show you right now is another video of this, well, software DVB-T cool stuff. What we now do have is a single frequency network, OFDM single frequency network with ETSI DVB-T transmission, which is completely, entirely implemented in software. We're using no hardware modulators and no hardware synchronizers. We're using no GPS timing synchronization, and we're just doing everything through Ethernet and an external oscillator. So we have a full SFN, which works with the traditional paradigm of fully software-defined radio. I don't think we have other examples of this anywhere. So what you see now in here is two broadcasting stations, station 1 and station 2. These are just two USRP2, which are frequency synchronized through this cable here, and which are connected to their host computers. The host computers will just be broadcasting the same signal, the same ETSI DVB-T signal, over the same frequency channel, which we will receive through this receiver here. So, the entire room is a true collision and interference area for the single frequency network. And the only thing which will be preventing those two stations from destroying each other's signal is time synchronization and a frequency synchronization of our software single frequency network. Okay, so here we go. We first do start the first modulator in here. So we have modulator 1, which we start like this. Then we have modulator 2, which is here, and we do start like this. And these modulators are now waiting for the time synchronization. Here we have a spectrum analyzer, which will just show us the signals. Now we have just some interference, which we don't care about in our interesting spectrum. Now we just go back and we start the synchronization of the system. From here we have a master machine which will do the synchronization. We start like this. We get back to the spectrum analyzer and we see a correct OFDM signal with almost no channel selectivity on it. And now we go to the receiver, which is here, which we can move around throughout the room, and it's receiving our signal. The volume, which is receiving our signal with no problems. Now we get back to the modulators. We just we switch off one modulator, like this, and we see that the receiver has no problems with that, and it's still connected. Now we see that the other modulator is okay, and we leave it running. We get back to the modulator which we have just stopped, and we start it again and leave it waiting for the synchronization signal. So this thing here is not broadcasting. How do you know it is not broadcasting? Come back here. The spectrum is much lower than it was a while ago. This is the transmission from only one transmitting station. Okay? Now we go to the synchronization machine and we start synchronization signal again. As soon as I start the synchronization signal, the transmission disappears. Now we have full interference and we cannot receive anything on this receiver. If we get back to the spectrum analyzer, what we see is that the signal, spectrum analyzer, is that the signal is strong again. Okay? Now I have just stopped the interfering transmitter, and the signal is back again, and the spectrum is lower as before, as it has always been with only one transmitter broadcasting. So what this demonstrates is that it is possible to achieve a single frequency network by using only software radio components and by using no GPS synchronization, but by carrying time synchronization signals only throughout a packet switch network. Thank you.